Hi, today I would like to talk about function and derivative. First of all, let me introduce to you what is function and derivative. Derivative in mathematics is the rate of change of a function with respect to a variable. Derivatives are fundamental to the solution of problem in calculus and differential equation. Derivative also help us to find whether the range of change is give maximum or minimum value. Let's see the problem statement. A manufacturer wants to make a cylinder can to hold 255 centimeter cube of soap. They want to cut the cost of the manufacturer by decreasing the size of the can. Find this dimension of such that the surface area is small as possible to cut the cost, and find the rate of change is give maximum or minimum value. Now, let's see the solution of the problem statement. First, we should find out this volume of the cylinder can hold 255 centimeter cube, and that the volume of cylinder is V equal to pi r squared h is the area of the top and the height. As you can see on the slide, I already provide the picture, and it must equal to 250 5 centimeter cube. And as question mentioned, find the dimensions such that the surface area is small as possible. Now we need to write the equation of surface area. 2 pi r squared is the area for two circles. Since it has two circles, we need to multiply with 2. And with rectangle part, 2 pi r h, the length of the rectangle is equal to the circumference of the circle, and we need to also multiply with 2. Now we are dealing with two equations. We need to rearrange one of the equation to eliminate one of variable. Now we are going to use volume equation and convert h to become subject. So h equal to 250 per r squared, and we can cancel the pi. Since we have h, we can substitute h into an area equation. You can see the detailed calculation on the slide, and the final answer is a equal to pi r squared plus 400 pi r minus 1. Let's see solution number 4. We need to find out the change in area is going equal to 0. So we need to differentiate this equation and set it to 0. After differentiate, we got dA per dr is equal to 4 pi r minus 500 pi r negative squared. We're going to set it to equal to 0. Now 0 is equal to 4 pi r minus 500 pi r negative squared. Going to rearrange this equation to find r. Bring negative 500 pi r negative squared to other side and put r as a subject, and r is equal to 5. Now, look back at the volume equation and substitute r into it, and h is equal to 10. Last but not least, the final thing we need to do is find either the r equal to 5 is going to give a maximum or minimum value. We're going to differentiate again the a equation, and the final answer we get 4 pi plus 100 pi r negative cube. Next, we're going to substitute r into the equation, and the final answer is equal to 12 pi. Since we got a positive value and d squared a per dr squared is greater than 0, the value is the minimum. So to conclude, h is equal to 10 and r is equal to 5, we can decrease the cylinder can size.
Today I would like to talk about matrix application. Before we move to the data parts about matrix, let's take a look first at what is matrix. Matrix can exist in a various forms such as tabular array for numbers, row, columns, and symbol operation. Matrix are mathematical operations that include addition, subtraction. Usually brackets are used to represent the matrix. Problem statement is the matrix are used to track how much supplies were sent to each cafe. Second, we will move to the background method of the matrix. The matrix multiplication is a binary operation that for matrix from two matrices. It is normally used in linear algebra. Move to the next part. Let's take a look at the problem statement and the methodology. Dessert is one of the most popular food. The bakery will supply cheesecake, muffin, and donuts to the Cafe A, Cafe C, and Cafe B. The price of one cheesecake is $50. For one piece of muffin, $5, and for one piece of donuts, $2. So first, we need to create a matrix for prices and supplies. The supplies will be calculated as 3 multiple 3 multiples 3, y prices will be calculated as 3 multiply 1. Take a methodology. What are the products of the two matrices of prices and supplies? For Cafe A, the product's profit revenue is $650, while Cafe B is $1,400, and for Cafe C is $1,550. So move to the next. For the total profit or revenue of all the cafes are $3,600. And lastly, for the determinant of the metric is $50,000. So that's all for the metric.
Next, I will explain about real and complex number. Complex number are numbers of the form x plus y in which x and y are real numbers and I is the imaginary unit, such as I equal to minus 1. A real number multiplied to the imaginary unit I results to an imaginary number. Here are imaginary number which is 2 is a real number and I is an imaginary unit. Here are some examples of complex number. Negative 4i, 5 plus 3i, negative 5 plus 2i. Next, I will explain about problem statement number 1. Given z equal to 22 plus 4i and z over w equal to 6 minus ai. In question 1, how can we find w in the form of x plus yi, where x and y are real number, and verify the modulus and argument of w? Methodology 1. Substitute z equal to 22 plus 4i into the equation, z over w equal to 6 plus 8i. And then we got w equal to 22 plus 4i over 6 minus 8i. Simplify the formula with a conjugate method, and the final answer we got w equal to 22 plus 50i over 25. And then we got final answer is w equal to 1 plus 2i. Simplify the equation in the simplest form, and the final answer we got w equal to 1 plus 2i. Next, to find a modulus w, we must use a formula modulus z equal to z in bracket x the power of 2 plus y the power of 2. From the equation that we find, we know x equal to 1 and y equal to 2. And then we must substitute the value of x and y into the formula of modulus z, and we can find the modulus of w. So we substitute the value, and we got modulus w equal to 5. Finally, to find an argument of w, we must use the formula of z equal to argument x plus iy equal to tangent inverse y over x.